Good morning, chemistry scholars. It looks like, based on your homework check, that there were 4 questions. Question 3D, 5B, 5C, and 5E that gave people the most problems. So I'm just going to review those 4 items from your homework, and I'll do that kind of using this same thing that I did the other day. So the first thing I gotta do is I gotta look at your homework. So the homework that you had was 3D. What does a cesium with a positive charge look like? So I'm going to start by drawing what cesium would look like. And in order to draw cesium, I'm just going to put a CS on the screen. Of course, the C should be capital. And cesium has 1 valence electron based on its position on the periodic table. So this is cesium. And for cesium to become a positive charge, that means that you have to lose the electrons. So cesium plus 1 would just simply be that. There would be no dots around it at all. So the biggest part there that you have to remember is when something becomes negative, it's gaining electrons. So this sulfur has 2 more electrons than what it normally would. When something's positive, it's losing electrons. Anytime that it's plus 1, it's lost 1 electron. If it's plus 2, it's lost 2 electrons, and so on. So, if I move down to 5B, that is CCl4, I'm going to set that up, so I'm going to pause the video. Alright, so I got C, carbon tetrachloride, ready to go. Step number 1, you got to determine how many valence electrons that you would have. So, I am doing that right now. I'm going to go to ptable.com. Just to show you how I figured out the number of valence electrons on ptable.com. If I'm looking for carbon, carbon's right here, so I'm starting over here from the left. 1, 2, 3, 4 valence electrons for carbon. And if I'm trying to do how many valence electrons are in chlorine, 1, 2, 3, 4, 5, 6, 7 valence electrons in chlorine. So, carbon has 1 atom of carbon right here. That's 4 valence electrons. Each chlorine has 7. That's going to give us, there's 4 of them, so that's 28. That's a total of 32 electrons. So the next step is to draw the simplest structure you can, keeping in mind we're trying to keep symmetry, not only to the left and to the right, but to the top and to the bottom. So if I'm trying to keep symmetry left, right, top, bottom, the easiest way to do that is to put these 4 items in something like this. I could put them all in a straight line, but it's actually more symmetrical top-bottom if I do it this way. So I'm going to put my bonds in. This is the simplest structure that I think I can draw. That includes all of the atoms. Remember, every one of these lines is worth 2 electrons. So what I have done is I've used 2, 4, 6, 8 electrons. And if I have used 8 electrons, I have 24 remaining. So I need to put my 24 in. 1, 2, I'm always going to put them in as pairs, and I put them in symmetrically, which means if I put 2 on the top, I'm going to put 2 on the bottom. And then if I put 2 over here on the left, I'm going to put 2 over on the right. And every once in a while, I got to stop and check to see, geez, just how many did I use? Because I can only put 24 dots in. 2, 4, 6, 8, oh, I got lots to go. So I am going to pause the video and continue putting dots in. Notice that I'm doing it very symmetrically as I go, but I'm pausing the video. And I do think that I used up all 24 electrons that I had remaining, so I'm just going to count to make sure. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Last step is to check for octet rule. And I want to make sure that all of the atoms have 8 electrons on them. 2, 4, 6, 8. Remember the line counts as 2. 2, 4, 6, 8. We're good. 2, 4, 6, 8. Still good. 2, 4, 6, 8. Good on that one. And then finally check the carbon in the middle. 2, 4, 6, 8. Everything's good. The only atom that ever wants 2 electrons around it would be hydrogen. And I don't have any hydrogen here, so everything is satisfied with the octet rule. I think I'm good for this one. Hopefully you guys got that one figured out. All right, the next problem that you said that you wanted some help with was nitrogen trichloride. So I am going to go ahead and give that one a shot. All right, I got nitrogen trichloride ready to go for you. I think there are 26 valence electrons looking at my periodic table. 1, 2, 3, 4, 5. Nitrogen has 5 valence electrons. Chlorine still has 7. That's not going to change since the last problem. So since there's only one nitrogen, that's 5 times 1. Gives me 5 valence electrons. There are 3 chlorines. 3 times 7 is 21. So that's where I get my 26 from. Simplest structure, I'm going to start with this and put it in the middle. I can't put things at angles. Remember, we are stuck going to the left, right, top, and bottom. You can't put something like off in a corner, because I suppose this would be a little bit more symmetrical if you really kind of step back and look at it. And we are going to adapt these. These are like our first step in these problems. So just keep in mind that they're going to look a little different in a day or two once we actually start drawing the 3D representation. This is a Lewis structure. It's how we do it in 2 dimensions. So I'm going to put my bonds in. Oops, I drew the simplest structure I could. Put my bonds in. And now I need to figure out how many electrons I have remaining. I have used 2, 4, 6. So I have 20 electrons remaining. I'm going to hit pause and I'm going to try to put those 20 electrons in. Again, I do it very symmetrically. If I put 2 right here on the top, I'm going to go and put 2 down here in the bottom. So I've now put 4 in. I have 16 left to go. So my goal was to get 20 dots in around it and make sure everything's happy. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I think I've done that. I am going to check to see if everything has an octet. Since I don't have any hydrogen, we just want to see. That chlorine has 8 around it. That nitrogen has 8 around it. That chlorine has 8 around it. And that chlorine has 8 around it. I do believe that I did put my remaining electrons in a symmetrical pattern, and everything was satisfied for the octet or duet. Last problem that you asked for help from your homework was CO2. So I am going to set that one up, and I'll be right back to show you how I solved that one. All right, here we go with carbon dioxide. First thing I do is figure out the number of valence electrons. I believe it is 16. I get my 16 by looking at the periodic table, and carbon has 1, 2, 3, 4 valence electrons. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So if carbon has 4, there's only 1 carbon. Oxygen has 6, but there's 2 of them. 4 times 1 is 4, 16 electrons. Simplest structure I can draw. Simplest structure I can draw, I think, is going to be a nice line like this. And put some electrons in. Next step, how many valence electrons do I have remaining? I used 2, 4 electrons, because remember each line is 2 electrons. So if I used up 4, I had 16. That gives me 12 left to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I didn't pause at that time because I wanted you to see kind of how I was putting those in. I put in all the electrons I have. If I counted everything, I should have 16. 2, 4, 6, 8, 10, 12, 14, 16. Let's check for octets or duets. And if I check for that, that oxygen is good. There are 8 electrons around it. This oxygen is good. There are 8 electrons around it. This carbon is not. There's only 4. So we have a strategy at this point. The strategy is to erase a pair of electrons. and then create a double bond. Notice this oxygen is still good, 2, 4, 6, 8. And by erasing this pair and adding it into the middle, the carbon is now closer to what it's supposed to be. And just like I use symmetry when I'm putting my dots in, I'm going to use symmetry when I'm taking my dots out. So, I do believe everything is happy now. 2, 4, 6, 8. There's 8 around this oxygen. 2, 4, 6, 8. There's 8 around this oxygen. And the carbon has 2, 4, 6, 8.